All right, guys, so today we're going to start by looking at gradients of a curve. And here's what we said. We said that the gradient of a curve at a point on the curve is equal to the gradient of the tangent to the curve at that point. So we've already looked at finding the gradient of a straight line and using the formula y is equal to m2 minus, m is equal to y2 minus y1 over x2 minus x1. And that is when we know the coordinates of any 2 points on the line. The gradient of a straight line is a constant, it doesn't change. However, the gradient of a curve is changing all the time. So for example, let's say we have a curve like that. So it's easy now to find the gradient of a straight line. You can just do that using calculation. For a curve, however, especially at this level, it's not so easy. At this level, what they would say is that you cannot directly find the gradient of a curve. Well, it's not exactly true when you go to a higher level, but at this level, you cannot directly find the gradient of a curve. But it is possible to find the gradient of a curve because the gradient of the curve is equal to the gradient of the tangent to the curve. So let us say I want to determine the gradient of the curve at that point. I can't really do it because at this level, there's no direct way to find the gradient to find the gradient of a curve. So I want to find the gradient of the curve at that point that I just draw. We can't directly find it, but here's what we know. We know that the gradient of the curve at that point is equal to the gradient of the tangent to that point. So what we'll end up doing is that we'll draw a tangent to the curve at this point. That will be the tangent. And essentially the tangent is a straight line that touches the curve at that point. It's a straight line that touches the curve at that point. So the tangent would look something like that. So I can't directly find the gradient of the curve, but the gradient of the curve is equal to the gradient of the tangent to the curve. So when I'm asked to find the gradient of the curve, what I do is I draw the tangent at the point and find the gradient of the tangent instead. And then now, once I know the gradient of the tangent, I know the gradient of the curve because the gradient of the curve at that point is equal to the gradient of the tangent at that point. I think what I just said just sounded very circular. All right, but if you think about it, it actually makes sense. All right, I'm just erasing what we just did before we actually dive seriously into the lesson. All right, so the gradient of a curve at a point on the curve is equal to the gradient of the tangent to the curve at that point. Now, what is a tangent? A tangent to a curve is a straight line that touches the curve at a single point. Another thing we'll be looking at in this section, and we didn't have it in the caption, we'll be looking at how to determine the equation of a quadratic curve when we're given the roots. Another thing we'll be looking at in this section is we'll be looking at how to determine the equation of a quadratic curve when we're given the roots. All right, so let's have a look at example 10. Example 10 says, the curve below is the graph of the function y is equal to ax squared plus bx minus 3. So the curve is the graph of this function. We don't know what a is and we don't know what b is. All right, and this is for the domain x is less than or equal to 1.5 and x is greater than or equal to minus 3.5. The tangent to the graph at the point 0, minus 3 is also drawn. So they draw the tangent to the curve at the point 0, minus 3. Guys, the first thing we're asked to do is we're asked to determine A and B. Remember, this curve is the graph y is equal to ax squared plus bx minus 3. We don't know what A is and we don't know what B is. Now, to determine what A and B is, we're going to determine what the actual equation is. In a sense, we're going to determine the actual equation where instead of A, we have a number, and instead of B, we have a number. By determining the actual equation, we can then say what is A and what is B. Guys, this is the theory behind it. The point where the graph meets the x-axis. So let us say the graph meets the x-axis here. And let us say that this is alpha, and here, let us say that this is beta, and let us say that this is our y-axis. Now, the point where the graph meets the x-axis, they're called the roots. They're called the roots. So we can say x is equal to alpha and x is equal to beta are the roots of are the roots of ax squared plus bx plus c. These are the roots. Now, from the roots, I can get the factors. So I can get the factors of the quadratic expression. To get the factors, my positive alpha, x is equal to alpha. Therefore, x minus alpha is equal to 0. Y is equal to, x is equal to beta. X is equal to beta. Therefore, x minus beta is equal to 0. Guys, x minus alpha and x minus beta are what you call the factors. They're factors of the quadratic expression. And if you multiply the quadratic expression, you will get the quadratic, if you multiply the factors, you will get the quadratic expression. So what that means is that ax squared plus bx plus c would be equal to x minus alpha multiplied by x minus beta. That is what they're saying. Ax squared plus bx plus c would be equal to x minus alpha multiplied by x minus beta. Now guys, x minus alpha and x minus beta, they are the factors. And if you multiply the two factors, the linear factors of a quadratic expression, you will get the quadratic expression. So now in this case, the roots are the x-intercept. So x is equal to minus 3 and x is equal to 1. Those are the x-intercepts. They are the roots. Now, if I'm about to bring over my minus 3 over to the left, I'm going to get x plus 3 is equal to 0. And I'm going to get x minus 1 is equal to 0. Now, whenever you do that, you can say x plus 3 and x minus 1 are the factors of the quadratic expression. And if they are the factors, it means that the quadratic expression ax squared plus bx minus 3 would be equal to x plus 3 multiplied by x minus 1. All right. And therefore, let's multiply x times x is x squared. X times minus 1 is minus x. 3 times x is 3x. And 3 times minus 1 is minus 3. So what we have now is x squared minus x plus 3x is positive 2x. If the signs are different, subtract and keep the sign of the larger number, minus 3. Now, if what is on the left is the same as whatever is on the right, it means therefore that a, which is the number in front of x squared, a, which is the number in front of x squared, is equal to 1. B, which is the number in front of x, is equal to 2. The very first thing we're asked to do is we're asked to find A and B, which we have just done. In order to find A and B, we have to use the roots of the quadratic expression in order to determine the factors. Now, once I have the factors of the quadratic expression, two linear factors, I simply multiply the two linear factors together to get the quadratic expression. Once I have the quadratic expression, I can equate coefficients. On the left, the number in front of x squared is a. On the right, the number in front of x squared is 1. So a is equal to 1. On the left, the number in front of x is b. On the right, the number in front of x is 2. So b is equal to 2. All right. So let's move on. Now, the next thing we're asked to do is we're asked to determine the gradient of the curve y is equal to x squared plus bx minus 3 at x is equal to 2. Remember, the curve is actually, the actual curve is x squared plus 2x minus 3. And that is why a is 1, b and b is 2. So we're asked to determine the gradient of the curve at x is equal to 0. Now, the first thing we need to do is identify the point on the graph where x is 0. Remember, the y-axis is the line x is equal to 0. The y-axis meets the curve at this point. The y-axis meets the curve at this point. So guys, that is the point on the curve where x is equal to 0. Now, the tangent to the curve at that point is already drawn. What we are asked to do now is to determine the gradient of the curve at that point. Earlier, I said, guys, you cannot directly determine the gradient of the point. What you have to do is to determine the gradient of the tangent, because the gradient of the tangent is equal to the gradient of the curve. The tangent is already drawn, so I need to know 2 points on the tangent. All right, here's a point. This point is on the tangent. This is the point 0, minus 3. This point also is on the tangent, and this is the point 2, 1. So the point 2, 1 is on the tangent. I need 2 points on the tangent so that I can calculate the gradient of the tangent, and I'm calculating the gradient of the tangent because the gradient of the tangent is equal to the gradient of the curve. So my 2 points on the tangent are 0, minus 3, and 2, 1. The gradient of the tangent m is y2 minus y1 over x2 minus x1. Therefore, m is equal to y2. Y2 is 1. This is y2. This is y1. x2, this is x1. So y2 is 1 minus y1, which is minus 3, over x2, which is 2, minus x1, which is 0. This is 1 plus 3 over 2, because a negative times a negative is a positive. And now we have 1 plus 3 is 4. This is 4 over 2. So the gradient of the tangent, which is equal to the gradient of the curve,
Good afternoon, sir.
Good afternoon, at x is equal to 0, that gradient is equal to positive 2. So the gradient of the curve at x is equal to 0, the gradient of the curve at that point is 2. The gradient of the tangent, which is equal to the gradient of the curve, is 2. All right, so next we're looking at example 11. It says the curve below is the graph of y is equal to ax squared plus bx plus 2. So this is y is equal to ax squared plus bx plus 2. All right, we don't know what a is and we don't know what b is. We're to determine the value of a and b. Now, if someone says to us, determine the value of a and b, technically, what they are saying to us is we are to determine the equation of the curve. Now, it is possible to determine the equation of the curve from the roots. So here we have a root and here we have a root. So the roots here are x is equal to minus 1 and x is equal to positive 2. From the roots, we can determine the factors. From the roots, we can determine the factors. Negative 1 on the right goes over to the left and become positive. So this is x plus 1 is equal to 0. And positive 2 on the right goes over the left, becomes negative. And we have x minus 2 is equal to 0. Now, x plus 1, if you want to put it in bracket, comma, x plus minus 2 are factors of my quadratic expression. If that is the case, it means therefore that y, which is ax squared plus bx plus 2, would be equal to x plus 1 multiplied by x minus 2. Oh, sorry. Erase all of them just right. Because this thing is a frown, you have to put a negative number in front. You have to put a negative in front of it first. So this is equal to minus x plus 1 multiplied by x minus 2. We can deal with the multiplication first before we deal with a negative sign. So negative x times x is x squared. X times minus 2 is minus 2x. 1 times x is x. 1 times minus 2 is minus 2. Therefore, we have minus x squared minus 2x plus x is minus x minus 2. Then give the negative sign. A negative times a positive is a negative x squared. Negative times a negative is a positive x. Negative times a negative is a positive 2. All right. So now, if whatever is on the left is the same as whatever is on the right, it means that a which on the left is the number in front of x squared, is equal to -1, which is the number in front of x squared on the right, and b on the left, which is the number in front of x, is equal to 1, which on the right is the number in front of x. So A is -1 and B is +1. The next thing we're asked to do is we're asked to determine the gradient of the curve at x is equal to 1. We're asked to determine the gradient of the curve at x is equal to 1. There are some steps that were given to you. It says, draw the tangent to the curve at the point on the curve where x is 1. Identify 2 points on the tangent, the coordinates of which are easily determined. 3, you are to calculate the gradient of the tangent using the formula m is equal to y2 minus y1 over x2 minus x1. B, you have to calculate the gradient of the tangent is equal to the gradient of the curve. So let's identify the point on the curve where x is 1. This is the line x is equal to 1. It cuts the curve at this point. So that point there that I circle is the point on the curve where x is 1. So this is x is equal to 1. Now at this point, I'm going to draw a tangent to the curve. Now a tangent to the curve is a straight line that touches the curve at that point. It is a straight line that just touches the curve at that point. So I'm going to draw my tangent. All right. When you're drawing a tangent, the tangent must touch the curve at the point. Notice it's just touching the curve at the point. All right. So that could be my tangent. So when you're drawing a tangent, it must be a line that just touches the curve at the point 1 and 2. It touches the curve at the point, and roughly the space on both sides is roughly the same. Space on both sides of the tangent is roughly the same. The thing is, the line is just touching the curve at that point. It must cut it. It must just touch the curve. Now that line is the tangent. What I have to do now is I need to determine the coordinates of 2 points on the tangent. 1 point I already know. The first point is 1, 2. This point is also at the tip of the tangent, so I could use it. This is the point 1, 4. This is the point -1, 4. So next I'm going to calculate the gradient of the tangent, because the gradient of the tangent at that point is also equal to the gradient of the curve at that point. So my points are -1, 4 and 1, 2. This is my x1, y1, and my x2, y2. M is equal to y2 minus y1, and this is over x2 minus x1. This is 2 minus 4 over 1 minus 1. up top, we have -2, and down by the bottom, we have 2. Gradient m, gradient m is equal to -1. So m, which is the gradient of the tangent, is equal to the gradient of the curve. At x is equal to 1 is m is equal to -1. The gradient of the curve at the point on the curve where x is equal to -1 is -1.